I want to practice solving for y. And when you're solving for y, it's very important that you understand what we're doing. We want to make everything, and let me take out some scratch paper. We want to make everything look like y equals mx plus b. Y equals mx plus b is our slope-intercept formula. And when we're solving for y, everything must look like this. So there are a few things you need to know about y equals mx plus b. The first thing you need to always do when trying to get it to look this way, notice the x term and the y term, they are on different sides of the equal sign. So make sure that your x and y terms are on different sides. So here, they're not. So we have to address that. Here, they're already on separate sides. So knowing that, that's one less thing I have to do. Look at this one. They're already on separate sides. So that's one less thing we have to do. Here, they're not on different sides, so I have more work to do. It's kind of like you told the X term, hey, go clean your room. And then the X term decided that they weren't going to, and so then they left and went out of town, and when you went in there, you had company coming over. Aw, man, what do you have to do? Unfortunately, clean that room or close it and hope nobody goes in there. But we don't want to do that. We don't want to leave it. If we're trying to make it look like y equals mx plus b, we have to move him over. Now we are looking at this one. They're on the same side, so we have to move that x term. Okay, so let's go ahead and move the x term. And after you move the x term, and after they are on separate sides, you have to move whatever is touching that y term. So it looks like we have a couple of steps here. Let's write the steps down. Step 1. You need to figure out if the x term needs to be moved. The reason I say you need to figure that out, because if the x term doesn't, I left out the word out, sorry. If the x term does not need to be moved, should you move it? No. Leave it where it is. Okay? Second step. Do whatever is required after you move the x term to isolate. Isolate. We want to isolate the y term. And when you isolate the y term, you're getting the y term by itself. So there could be more than one thing we have to do to isolate the y term. There could be more than one thing we have to do or not do to figure out how to move the x term or figure out if it needs to be moved. So let's take these two steps and let's work out number 1. Do I need to move the x term? Yes, because they are not on different sides. So how do I do that? Well, he is positive, so subtract him. That's the inverse operation. Bring down 3y, you don't have to write the plus sign. Now, this part I know you're not going to like. And I'm going to write negative 2x first. Let me tell you why. Because mx was first. Now, some of you are not going to like this. I already know. I know you're not. And you're going to come down here and write 4 minus 2x. Is that wrong? No, it's not. But I want you to practice writing 2x, negative 2x, because the negative belongs to the 2. And I want you to practice writing what the 4 would look like behind it. Well, what is that? It's a positive, so you write a plus sign. You think we need to practice that? Yep. And what's going to happen if you keep writing 4 minus 2x? you will never develop this skill. So I want you to develop that skill. Now, 3 is multiplied to y. So to isolate the y term in this problem, we're going to divide by 3. Whoa. So what does that mean? Well, this is 1. So this is just y. And why is it isolated? Now, can you write 1y? Sure, it's the same thing. And what does that mean? Negative 2 over 3, put the x in the middle. Or at the top, it's the same thing. Plus 4/3, and you are finished. You cannot combine them because he doesn't have an x. So this is y equals negative 2 over 3x, and the x can be at the top. Let me wipe that out real quick, because I was rewriting it so that you could see that the x can go at the top. So let me do that. I want you to see that it's the same thing. See? You can write it like that. That means that. And then plus 4/3. Now, which one are you going to see me write most of the time? 99% of the time, I'm going to write this one, because we're getting ready to graph lines. And this is what they're going to look like. Let's do number 2. Number 2 says, figure out if the x term needs to be moved. Well, are they on different sides? Yes, they are. So let's do that. And now that they are on different sides, what's the next part? Because there's nothing to do. So, sorry about that. There's nothing to do here. So, now we isolate the y term. Uh-oh. Is the y term by itself? No. So, what do we do? Okay. Well, I know to add or subtract first, and then the one touching it, do it last. So, what do? I subtract. So, when I subtract, can these two go together if he doesn't have an x? No. So this is 3x minus 2. And that equals 4y. So to get y by itself, and that's multiplied, divide him off. So I'm left with y equals 3 over 4x minus, and hopefully, I'm hoping you reduce that to 1/2. Okay, let's do the next one. X and y, are they on separate sides? Yes, they are. So what are we going to do? Isolate the y. How do we do that? He's multiplied, divide him off. What's my final answer? That goes to 1. And this is 2x, because 8 divided by 4 is 2, minus 2 divided by 4 is 1/2. Okay? If you needed to put this in the calculator and use it as a resource because you're not that strong in reducing, could you? Yes. Do I want you to do it by hand? Of course I do. But if you have to use this, can you type in 8 divided by 4 or control divide 8 over 4? Yes. 2. Let's do number 4. Y and x, are they on different sides? No, they're not. So what do? We move them. You notice how the x term is here and not first? So plus 4x plus 4x. Now I'm left with 3y. Now is that 10? No, it's 4x plus 6. Write them separate. They're different. This is a constant. That's the x term. Now divide by 3. So y equals 4 over 3x plus 2. Now, 4 over 3. Some of you might not know you can reduce that. So control divide 4 and then 3. When I press enter, if it gives me the same fraction, I know it's reduced all the way.